Hi, Ms. Likeness. Today I'm going to talk to you about this graph. So, this graph is comparing income to life expectancy. The other two variables we can see in this graph is for the size of the bubbles, we're using population size. So, for example, this bubble right here, it's the biggest one in the graph, and as you can predict, that is China because China has the biggest population in the world. And then the second one for the color of the bubbles, it's where it's located in this map right here. So, for example, all green bubbles are from the Americas, all blue bubbles are from Africa, all red bubbles are from Oceania or Asia, all yellow bubbles are from Europe and or Russia. And yeah, so to analyze this data, I did a line of best fit, as you can see right here. And my line of best fit, my initial value is the point 0.070. This point means that even if you have a income of 0, you have a life expectancy of 70. And every time the life expectancy increases by 10, the income increases by 80. So I simplified this to 1/8, and that was my rate of change. So as you can see right here, my equation was y equals 1/8 x plus 70. So the association in this graph, I believe that it is a positive, moderate, nonlinear association because this graph is not on a straight line and it's more of a curve, as you can see right here. So for my interpolation point, I chose the point 4075. So a statistician might expect if a country had an income of 40,000, a statistician might expect the country to have a life expectancy of 75. So right here, you can see the equation that I did. So I used my equation and I replaced x for 40, and 1/8 of 40 is 5. 5 plus 70 is 75. So for my second prediction, if a country had an income of 180,000, a statistician might expect the country to have a life expectancy of 92.5 years. So I did the same thing that I did in the last equation, but this time I replaced x for 180. And then 1/8 of 180 is 22.5. 22.5 plus 70 is 92.5. This seems somewhat unrealistic. For my conclusion, in 2019, an average citizen in Panama had a life expectancy of 81 years and an income of 44,000. What surprised me the most about this data was that Panama had a very high life expectancy. It is within 5 years of the highest life expectancies in the graph. Also, when we compare Panama to the line of best fit, it is above average. Brazil is also above average. In 2019, an average citizen in Brazil had an income of 15,000 and a life expectancy of 75. So what conclusions can we make about this data in general? I think that there is causation because a better income paves the way for a better quality of life. Also, if your income is higher, then you're required to pay more taxes, and then the government builds more hospitals, schools, roads, and therefore they improve life expectancy because society would be much safer. So what do I think is a lurking variable right here? So a lurking variable that I think I noticed was that the rich to poor ratio. In Panama, the rich to the poor ratio is much smaller than the one in Brazil. This is because Brazil has 210 million people, and the majority of those are considered poor. Panama has a different situation because their population is of 4 million people, and the rich to poor ratio here is much lower than it is in Brazil because Panama has some tax laws that persuade people with more money to come here. This tactic has worked as Panama's economy has thrived throughout the last 20 years. So what does this data mean to the world? This data means that it shows the world that to improve their life expectancy, they should focus on improving public health, they should create more jobs to improve their economy, and they should also build safer roads and better schools so that their economy would thrive and the country would be much safer as a whole. So how might someone misinterpret this data? Let's say you're from Panama. You might misinterpret this data by thinking that you would have your life expectancy was of 81 years. This is only an average. It's not for certain because everyone has different health conditions. So the equation of the LSRL is y equals 0.0002x plus 68.8. And my equation was y equals 1/8 x plus 70. So my predicted initial value was very close to the one of the Desmos line of best fit, but the my rate of change was very off. So what does Desmos do to calculate the LSRL? Desmos squares the residuals so that there are no negative numbers. After this, they add them up and they try to minimize the residual as much as possible. So the coefficient of my data is 0.7. I consider 0.7 to indicate that the data has a moderate association. I don't think it's a strong association yet. I think for it to have a strong association, I would need my data to be 0.75, and because then I could round up to 0.8. For me, a strong association would be considered from 0.8 to 1.